In the next 40 minutes, we're going to start with some slides explaining some of the concepts at a high level of the idea of modern application design. We're then going to put those ideas into practice as I demonstrate how to build a REST interface and connect that to an AngularJS application. After that, we have a couple of extra points of interest, some topics, things that may come up as you develop your own applications, and then we have time at the end for questions. Okay? So the topic is modern web applications, and I think it might be interesting to highlight the difference between what's modern and what's not to see how far we've come. So way back when, we had server pages, and the dominant idea with technologies like ASP, JSP, PHP was that the entire state of your application was maintained on the server where all the code was. So quite often you would have things like database updates right alongside code to dynamically display pieces of your UI in the browser. So as you can imagine, it can get a little difficult to write, difficult to maintain, difficult to test. You have to stand up an entire server just to get the thing running. But fortunately, we've kind of come a long way. We've learned that the best way to develop these things is to have different pieces working together, and you can develop these pieces independently. Each one has its own purpose. And if you do any kind of reading into this topic, you're going to see this acronym come up, MVC, Model View Controller. These are the fundamental pieces of any application that you'll see. And I'll show you a diagram to explain how those pieces fit together. So, of course, you have the data that's going to be displayed and maintained in your application. This is your model. You have your view, which is anything the user will see or interact with, all your tables and forms, buttons, things like this. And in between the two, we have the controller, which is all the code to delegate user input and make some update happen to the data. And if the data has changed, we need to update the user's display so they can see what changed. Now, for web applications, it gets a tiny bit more complex. I'll show you the schematic of the application, the example that we're going to develop today. As you can see, it looks very much the same, but the controller piece has been separated by this REST API, this web service that lives on the server, and we're listening for incoming requests, and then the control flow is basically the same. And as you'll see, the advantage and flexibility of developing things this way is that both of these pieces really can be independent. You can have your client, which in this case will be an AngularJS application with HTML templating and JavaScript code. And really all that does is calls into this API that exists on the server. And over here in our Caché instance, we have data storage, of course, but we also have some code to use our web service and listen for incoming requests. So, to make sure we're all on the same page with REST, what does it mean when I talk about REST? What does it mean to say a web service is RESTful? And it means a lot of things, but it helps to understand that REST is a series of best practices, a design paradigm that exists on top of the HTTP layer that you use every day in your browser. When you make a request to any web server, there's two pieces of your request. There's the type, or HTTP method, that indicates what you want to have happen on the server. What do we expect to see? And also the resource, the named item on the server that we're going to interact with. So in this case, it's a GET request, as you see on the left. And the resource is going to be something called tasks at the end of all the slashes. So looking at that, you can understand that we're going to retrieve a list of task objects. This might say person with an ID, and that would indicate we want to get the data for one person record. And so I said REST is a lot of things, but one of the fundamental principles that it tries to impart upon you is when you're designing your web service, you should expect requests to come in with a format that clearly indicates what we expect to have happen on the server. So things like this, where you have a verb, in a sense, on the left-hand side and a noun on the right-hand side. And this table here is just a correlation between action on the server and the commonly used HTTP method. So as I said, a get indicates we're returning data. You can post and create a new record. You can have a put to update a record, and so on. For our data payload to and from this server that we're going to develop in a few minutes, we're going to be using Json. Pretty widely used, kind of self-explanatory data format. You have a list of key value pairs there. But what I want to bring to your attention right now is something we added to the product very recently, in just about the last year or so, that makes working with this format really very simple. This is our dynamic object API. Now what you can do is create a schemaless object and interact with that using the dot syntax as if it were any other object in your database. And you can do this with the traditional JSON syntax, with one exception that I will highlight when we get into the code. So that whole line of code there will create one of these dynamic objects. Now to serialize that and bring it back into JSON, you can call this method here, %toJSON. And that will return the string representing that data that we can use for whatever we want. If you want to go the other way, if what you have is a stream or a string of JSON formatted data, and you want to turn that back into an object so you can use the dot syntax, you can call this class method right here, %fromJSON, passing in whatever piece of text you have. And we're going to make use of both of those methods pretty extensively in this application we're going to develop in a few minutes. Last piece of the equation is AngularJS. This is Google's web framework, their templating language that kind of simplifies the client-side application development. But I don't want to focus specifically on the implementation of the client in this session. There are a few other sessions at Global Summit this past week that talked specifically about Angular development. But my idea, and what I hope you'll take away from this, is what's on this slide that I'll show you again. So the client and server are really independent in this case. The server, the Caché instance, has its web service, and we're listening for certain types of requests. Once that's set up and the specification of our API is fixed, the client can be anything. We can have Angular on here. You can have something like React.js, which is Facebook's iteration on this. You could have a native mobile application that calls into this API. There's a lot of flexibility with this approach, as I hope you'll see in the next few minutes. So let's get into the specification, the outline of the application we want to develop. This is going to be a to-do list. Sounds very simple, but this will actually demonstrate the full spectrum of things you'll need to be aware of and write in your own REST service when you go to develop a more intricate API. So we have a list of tasks. There's some that are more important than others, and we'd like to be able to see that. We want to be able to check the list of completed tasks. We want to update tasks, create new tasks, delete tasks if we don't need them. So the first step is to create the REST API. So let's go ahead and do that. Our first stop is going to be the management portal, where we need to create a CSP application that's dedicated to our REST interface. And I'll explain the reason for that. I'm going to call this GS API. And the critical setting that you need to be aware of is this one right here, dispatch class. When I set this up with the name of a class, a Caché class in this namespace, it's going to change the traditional behavior of the CSP application. If you're familiar with this at all, when you make a request, ordinarily what we'd do is look for a file or some kind of CSP page or a Zen page. If the dispatch class is set up, what we'll do instead is route that request into this class that you create, and then we can have our REST API try to match the requests with different routes that we've defined. If there is a match, we're going to call a method on the server. So I'll open up Atelier, our new IDE, where I have the todo.rest class. It already exists. Now, your dispatch classes need to extend %csp.rest. That's the one thing you need to be aware of right off the bat. And there's one piece of boilerplate code that we need to copy out of the parent in order to get started. This is going to be our URL map, which is the list of routes, the pairs of HTTP method and source name And if we get a match, we call the associated class method in our dispatch class. So I'm just going to copy this, and I'll explain all of this. It's just a simple little XML structure here. And if I want to add a new route, which let's go ahead and do to demonstrate this, I just add it inside of the routes element here. Now, there are 3 attributes that you need to be aware of. First is URL, which is the resource name on that last slide that I showed. You don't need to put in the CSP application name here because we've already passed that point in the processing. So you just write what you want to appear at the end after everything. So let's just do /test. The next attribute is called method. This is the HTTP method that we expect to see. It's not the name of the class method. So just keep that in mind. It can get a little tricky if you're not careful. Let's look for a GET request. And the method we want to call, the third attribute, will also be called test. All of the methods in your dispatch class are going to be class methods, and they all return type %status. What I recommend doing here is to just quit one out of each one of your methods if you can. If you don't, we are going to enter the traditional Caché error handling. I'll show that to you in a few minutes, but you don't really have any control over what the error message is. There are better ways to handle problem situations, which I'll show you in a few minutes when those come up. If you want to return data from the API, all we need to do is just write a string. We'll just use the open device that was created when the request came in and just return that string. So I'm just going to write test and then quit. And we'll compile that. I'm going to introduce Postman to you. This is kind of the industry standard tool for testing REST APIs. It just gives you a lot of flexibility to make different types of requests. So what I've done here, I'm saying it's a GET request. We have the server and port, the CSP application name, and then the resource /test. So when I click send, we see the text that was returned. But what I want to return instead is JSON, not just flat text. So let's go ahead and do that now. I'm going to create one of those dynamic objects that I mentioned with the curly braces like this. And we'll just put down a few key value pairs as a test. And now, here's where we break from the traditional JSON syntax, as I mentioned before. If you want to have an expression appear within the contents of your dynamic object, you need to enclose that in parentheses so that the compiler knows what it is. Otherwise, you'll have a syntax error. So if I wanted to grab the current date, let's say, using $h like that, it needs to be in parentheses. So we have our dynamic object. Now let's serialize that back into JSON with the %toJSON method. We'll save that. Back in Postman, I make another request. There's the JSON for the dynamic object that we created. So let's get started on building out that API. The first thing in our specification was to return the list of task objects. So let's do that. For our URL, we want to have /tasks. We don't need to write something like get tasks here because the HTTP method will indicate what we're doing. But for the class method name, it helps to make that clear. We'll write get tasks. I've got a little bit of code to write here. I need to set up a result set. And I've already created this class beforehand, todo.task, which contains some pre-populated data. Next thing I need to do is create the dynamic object that we're going to use to return the information. So I'm going to use the key tasks and put down square brackets. This is a dynamic array. So we're going to add elements to this array. I need to first pull those out of the result set, like this. And of course, these are all expressions. The %get method to grab that column out of the result set, so we need to wrap that in parentheses. And then, if I want to add this newly created dynamic object to our array, I can use the method called %push, like that. Serialize that back into Json. We'll go back to Postman and see what we get. And there's our list of tasks right there. I can actually make that look a little bit nicer. The next thing we need to do is introduce the AngularJS application that I mentioned to you at the beginning. So let's do that now. Here it is. We have a nice little header right here. There's a button to create a new task. There's an option to show completed tasks. But there aren't any tasks yet because we need to add the reference to this API method that we just created to the Angular application. Now, as I said, I'm not going to go too much into the implementation of AngularJS, but I will show this piece right here. This is an Angular service that I've created as a wrapper for the HTTP requests into our REST service. So all I need to do here is call into Angular's built-in $HTTP service and just return the result, the promise object of the, and my controller code is going to handle the rest. So I'll actually just copy this URL right from here. We'll save that. If I reload, there's my list of tasks in the application. So what we did is we just called this method of our REST service and just populated the UI with that data. Next up is to give us the ability to create a new task. So let's do that. We can use the same piece of the URL, the same resource here, /tasks, because we're not referencing a specific task. We're going to add something to the list of all tasks. And the way we'll differentiate this method from the previous one is to have this be a post request instead of a get. So I need to grab the incoming data for this request so that I can build up the new task object. And I'll show you how to do that right here. I'm going to call that class method that I mentioned, %from JSON. But where does our data come from? What I can do is use the special variable %request and the property .content. So when you make a post request or a put to the server, if there's a form that's being submitted, the data will wind up here. So I'm just going to take that. We expect it to be JSON and then turn it into a dynamic object. I need to create a new task to be able to save. Get that out of there. And now I need to pull the properties from here, from my dynamic object, and set those up in my persistent object that I'm going to save. So I can just use the dot syntax to do that like this. If the task is new, it hasn't been completed, so we'll set that to 0. And there we go, and we've saved it. So let's demonstrate that in Postman. I'm going to change the method type to a post. Over here on the body tab, I'm going to just build up some key value pairs. I'll go ahead and submit that request. We got a 200 OK status back. That indicates that everything went well. And if I reload my list, there's the new task that we just created. Now, I mentioned error handling to you before. Now, if, for example, we tried to create a task, but we didn't specify any text. There was no description of what it was. How do we tell the user that they've done something wrong? Well, and I'll explain a little bit about how the dynamic object API works. This reference right here, obj.text, if for some reason we didn't have that key in our object, this would just return an empty string. There's no key error there. So what I can actually do is capture both cases where you sent us something but it was empty, or you just missed that key altogether by saying if the length of that value is 0, and now we need to return an error, and I'll show you how that's done with the special variable %response, the companion to %request. I'm going to use the status property. This is where I can just write something for our HTTP status code. You saw before we had 200 OK. I can put my own value in here. So I'm going to say 400 bad request. You can put your own value there, but you should really try to follow the conventions of the HTTP status codes that are commonly used. So we're going to say it's a 400 error, and we're going to quit 1 because we want to stop executing this method. We don't want to finish creating this object. So if I go in and try that again, and I take this field away and try to submit again, what we got is the bad request error. But if I put that back, and submit again, that one worked. So the next step is to add that method to our Angular app. That goes here. We're going to change this method call from a get to a post. And there's form data coming in from the application in this argument right here. And so the way this works is you just add that as the second argument to your method at the end. And there's the new task that I just created in the application. Next step is to allow us to update an existing task. And there's two pieces to that. We need to first have the ability to get the details for a specific task so we can populate the form with information and then do the update. So I'll show you how that's done right here. It's very, the URL is going to be the same for both of these. We're going to use task in the singular this time because we're pointing to a specific task. And we're going to have the named argument ID. So you put down :ID to indicate something will be here in the URL, and it will be a named argument called ID. The method's going to be a get. We're going to say get task. So that ID argument actually winds up here in the argument list for the method. And what I'm going to do is just open it, try to open that ID just with what you gave us, and then build up my dynamic object. OK. So back in Postman, we'll run another test. We'll say task 1. And there's our data. Now, I mentioned before, when you're writing these methods, you need to quit a status code of 1, or else something kind of unexpected will happen. I'll show that to you right now. If we try to grab the data for a task that clearly doesn't exist, task of ID 100, what you'll get is this. So what we've done here is take the Caché error status code, because an exception was thrown when we tried to use that task object. And we just decomposed that into JSON and put that here. Now, maybe this is fine for your API, but if it's not, you need to catch those exceptions and do your own error handling in the REST class. So just be aware of that. But what I'm going to do instead is just check to see if this object that we tried to open doesn't exist. We're going to return the familiar 404 not found error. Show that in Postman. There you go, 404 not found. We don't really need any other information about the error. It's kind of obvious what the problem was. You are free to put any kind of information here. If you wanted to write some details about the error message, you're free to do that. But it's not always necessary. Make sure that still works. OK. Let's add that to our Angular app. The URL is going to be task, and we'll just concatenate the ID parameter onto the end of that to build up our request. So if I click to edit that task, you see the text is filled out in this form, and the important box is checked off. So let's give ourselves the ability to update a task. As I said, the URL here is going to be the same. It's going to be an update of an existing record, so that's going to be a put request. By convention, post indicates that we're creating a new record, and put indicates we're updating an existing record, just to let you know. We'll say update task. Now, I need to combine both methods of retrieving data from the client with this method I'm about to write, both the named argument and this %from JSON, grabbing things from the incoming request data. So let's go ahead and do that. And I can actually just copy pieces of the other methods and put those in here. So obviously, we need to open the task object in order to edit it. And if we don't get one, we should return an error. So I'm going to just copy this block right here into the update method, like that. We need to grab the data that was sent to us from the client. So I'm going to grab this piece of code. Let's put that in at the top. We need to save the object. And now I'm free to write the rest of my method. Now, the way that I want to do this, to give myself a little more flexibility in the API, let's have it so if the key doesn't exist in the incoming JSON string, we just won't update that property. We'll only change the things that the user specified that they wanted to change. And I'll show you how this can be a little useful in a moment. But the way to check whether a key exists in the dynamic object is to use the method isDefined. So if the text key exists, let's set it based on what's in our dynamic object. And I'll just copy this 2 more times for the other 2 properties. So if the important flag was changed, we're going to update that based on what was sent. If we're marking a task as completed, let's update that as well. Back in Postman, the important flag for this task is set to 0. So let's change that to raise the priority of this task, making dinner reservations. Set important to 1 here. We'll send that request. Got a 200 OK, so everything's good. And if I retrieve the data again, you see the important flag's been set to 1. Back in our Angular service, let's go ahead and set up that method. Now, as I said, we need to send 2 pieces of data, the ID and the form data. So if I make this a put request, I can do the same thing. Just add a second argument and put the data. I'm going to reload that. And there's the update to my task that I just made. Now, the reason I wanted to write the update method in that way was to make it simple to add another piece of functionality to the app, the ability to mark a task as completed. So if I click this button here to do that, it doesn't have any effect just yet. But if you think of it, saying a task is completed is really just another kind of update. So what I can do is actually copy this method that I just wrote. I can put that in here in the finish task method. And instead of taking data from the form, I'm just going to send my own JSON object. We'll just say the update is going to be to set completed to 1. And then I can start marking some of these things off. And if I click Show Completed, you see we have a few extra tasks that you didn't see before, marked in gray because they're finished. And if I reload, the data persists. So the update was good. Last step is to allow us to delete a task if it's no longer necessary. The URL is going to be the same again because we're referring to a specific task. That's going to be a delete. Call that delete task. Now, if the task doesn't exist, let's return that 404 error again. Otherwise, just delete it. Like that. So back here in Postman, you can see this task clearly exists, but if I change the method type to delete, there you go, 200 OK, the task has been deleted. If I try to grab it again, we're going to get the 404. If I try to delete it again, we're going to get 404. So our error handling is good. So let's add that to our Angular service and round out the API. We're going to say it's a delete. We have our URL with the concatenated ID at the end. Click the delete button here. And as you see, that task is now gone. It's not in either list. So that finishes our API. So let's talk about a few extra topics here. Let's talk about cores. This is something that's going to very likely come up as you begin developing your own applications with your own REST API. And I'll show you an example of how you're usually going to encounter the world of cores. Our API is hosted at this web server right here, which is the private Apache web server that comes included with Caché. If, for example, your application was not hosted by this server, if it was a flat file on disk, like, let's say, in this file, which is just on disk, it's not hosted by a web server, if I try to reload that, you're going to see this error right here, access control allow origin. No header is present on the requested resource. And if you look into this, you're going to learn about something called CORS, cross-origin resource sharing. This is a security measure, an agreement between your browser and the server you're trying to contact. And it's actually a very good thing, but it can sort of get in the way in the beginning of your application development. So I'll explain how to get around this and address this in a moment. But it's important to understand the situation that it's protecting against. As an example, let's say that you were doing something on your bank's website. And your bank has a REST API, a modern web application. It's got HTTPS, you've got a 50-character password. There's no way you're going to be able to break into your account information. But what can happen is, if you were, let's say, on a second website, and it had a piece of JavaScript that ran, and there was a request in there to contact the bank's API and just grab the information for your account. Well, you might say, there's no way that can happen, because how would the second party know what my account information is? Or they wouldn't be able to log in because they don't have my password. Well, the situation that the core's security was designed to prevent is actually a case where your browser's willingness to help you be more efficient can work against you. Because you've logged into the bank's website, you have a cookie that maintains your session between the browser and the server. So when your browser runs that code to make the request, it's going to just log in for you automatically. And then your real data will be sent back to the browser, and then this malicious person might just say, OK, now that I've got the data, just send it to my hacker server, where I can do whatever I want to your account. So to stop this from happening, the server checks the origin of the request, which is the server that decided to make this second asynchronous JavaScript request to the other server. And if the origin doesn't match, if, let's say, the request didn't come from the bank's website, we don't allow the request to continue. And you'll see this error appear. So that's kind of the importance of the gravity, I guess, of the situation that we're dealing with. But this is going to kind of bite you when you start to develop your API. So the way to address this is go into your class. You can do one of two things. You can specify that one particular route will have cores enabled. You set cores equal to true. So if I go back here and reload, now we're going to see the data that we expect to return back. I can also add a parameter to the class called handleCoresRequest, set that to 1, and that will take effect on all routes for this REST class. So what we do here, and this is all documented, and I encourage you to read some more into this later, when we say we want to actually handle the cores request, we have the option to decide which origins are acceptable and which ones are not. And there's a callback method in here that you can override in your class to go ahead and make that happen. But by default, if we're saying we want to handle cores requests, we just allow every one of them through. So just be aware of that. This is not something that you'd want to enable for your public API without at least some serious consideration. OK, second topic I want to address, how to secure your REST API. And it's as simple as just changing the allowed authentication method from unauthenticated to password for this CSP application that was set up with the dispatch class. So if I go back here to Postman, and we'll say just give me the list of all tasks again, what I get, the 401 indicates we need to log in. I can go ahead and do that actually with this authorization header right here. We can say basic authorization with my Caché password. If I click send, we got 200 OK. There's the data that I expect to see. In the Angular application, we have something quite similar. You're going to see this login screen appear. This is the browser doing this automatically. It detects the 401 error and displays this to you. I didn't include this in the application. And if I put the username and password in there, we go ahead and log in. There's ways to detect that situation if you wanted to write your own login page, let's say. But this is the browser doing that for you automatically. OK? Well, that about wraps it up for today. If you have any more questions, you can find me, Michael Smart, in the Tech Exchange after this. Or you can talk to Stefan Whitman, making his very timely appearance in the room back there. He's our product manager who can address all your very technical questions. Extra resources that you might want to be aware of. We have learning.intersystems.com, our wonderful website with, as John mentioned earlier, thousands of courses and resources for you to take a look at. I want to highlight one right here, 622, Setting Up REST Services. I had a hand in putting that together. It's really a great course if you want to do some hands-on stuff with what we've discussed today. And then, of course, the developer community can put you in touch with other developers and InterSystems staff, and we can talk about these things all day long. Please go ahead and fill out the survey in the Global Summit app, and watch out for the recording and slides and the example code that you saw today to be available after the summit is over. Thank you very much.